Hello everyone, I hope you are doing very well. In this video, I'm going to demonstrate how you can perform forward and backward stepwise multiple regression analysis in EQS. So this is my dataset, and on the right hand side of this dataset, I have calculated scores for interpersonal conflict, role conflict, positive affect, negative affect, job performance, and job satisfaction. In the first example, I'm going to perform a forward stepwise multiple regression analysis, and I would like to check whether these four predictors can predict job performance. To do so, what I need to do is to click on analysis menu, and then from here I will select regressions and then a stepwise multiple regression. Please note that there are two options here, forward stepping and backward stepping. Since we are going to perform a forward stepwise multiple regression analysis, I will select the first option, and this F ratio indicates whether a new variable can be entered into the model. So as long as the F ratio of any variables, any predictors is greater than 3.84, they will be considered by EQS to be entered into the model. Similarly, when you are performing backward stepwise multiple regression analysis, if the F ratio of any predictors is less than 2.71, they will be dropped from the model. So these two statistics here, these two values that you can see here are basically the default and are widely used. Of course, you will be able to change them based on some statistical and theoretical grounds, but we just leave these values to be the default. Now we have to select the predictor variables and the outcome variable in our forward stepwise multiple regression analysis. So our outcome or dependent variable is job performance, and our predictors are interpersonal conflict, role conflict, positive affect, and negative affect. I also ask EQS to save regression estimates and residuals in the dataset by clicking and selecting this option. Now let me click on OK, and you will be able to see the results. In the first step of forward stepwise multiple regression analysis, there will be no predictor variables. That's why you can see a F statistic of 0 and the p-value of 1 here. And you can also see some other statistics such as the Durbin-Watson for this particular model in which there is no predictor variable. That's why in the regression coefficients table, you can only see the unstandardized value for the intercept because there is no predictor in the first step. Then you can see the F ratios for different predictors that we would like to add in this model. And since the F ratio of positive affect is greater than other F ratios in this table, in the second step, positive affect will be selected by EQS to be entered into the model. So when this predictor is added to the model, we will have another analysis of variance results here. So the F statistic is 87.398 and the p-value is 0, and you can see that the only predictor in our model, which is positive affect, can predict 8% of the variation in job performance. And here in the regression coefficients table, you can see the unstandardized and the standardized pass coefficient for positive affect. And you can also see that this effect is statistically significant. Then we have another set of F ratios, and if you compare them, you can see that the F ratio for role conflict is greater than the other two F ratios. So in the third step of our forward stepwise multiple regression analysis, role conflict will be added to the model. Again, we have another F statistic and p-value. You can see that the two predictors, including role conflict and positive affect, can explain 9.45% of the variation in job performance as the outcome variable in the model. And you can also see the unstandardized and standardized pass coefficients for these two predictors. And based on T statistics and p-values, you can see that the effects from role conflict and positive effect on uh, job performance as the outcome variable is statistically significant. Then we have another set of F ratios, and if you compare them, you can see that the F ratio for negative affect is greater than the F ratio for interpersonal conflict. So in the fourth step, negative affect will be entered into the model. Again, we have another analysis of variance results here, and the F statistic changes to 38.316, and it is statistically significant. You can see that the three predictors, including negative affect, role conflict, and positive affect, are can predict 10.35% of the variation in job performance. And here you can also see the pass coefficients, the unstandardized pass coefficients and the standardized pass coefficients. And you can see that based on the T statistics and p-values, these three predictors are significant predictors of job performance. Then we have uh, another table for F ratios, and basically there is only one F ratio here, which is the F ratio for interpersonal conflict. And as you can see, this value is smaller than our threshold value of 3.84. So EQS will not enter this predictor into the model. And basically, we can only have these three predictors: role conflict, positive affect, and negative affect as the significant predictors of job performance in this model. Now, let me just go to the data set because we requested EQS to save the predicted values and the residuals. And again, if you would like to create a scatter plot for the predicted values and the residual versus residuals, you can simply click on this button here and select the predicted values and also the residuals, and you can have this scatter plot. You will be able to save this file and use it in your thesis or paper as well. So let me just close this. Now in the second example, what I'm going to do is to run a backward stepwise multiple regression analysis, and this time I'm going to select this option. I'm not going to save regression estimates and residuals to the data set this time, so I just need to select my outcome variable as well as the predictors: interpersonal conflict, role conflict, PA, and NA. So in the first step of backward stepwise multiple regression analysis, all of these four predictors are entered into the model, and based on the criteria that we have here, they will be dropped one by one from the model. So let me just click on OK, and you will be able to see the results here. So in step one, all of the four predictors have been entered into the model. This is the F statistic and the p-value. And you can see that the four predictors can predict 10.47% of the variation in job performance. And then we have the regression coefficients table here. You can see the unstandardized pass coefficients for the four predictors. You can see the ordinary standard errors as well as heteroscedastic standard errors. I told you that these standard errors are more accurate when the assumption of homoscedasticity is violated. Then you can see the standardized pass coefficients and the T statistics and the p-values. And note that the p-value for interpersonal conflict indicates that interpersonal conflict is not a significant predictor of job performance. Also, you can see the F ratios here in the last column. So you can see that this value is smaller than 2.71. So EQS will remove interpersonal conflict from the model in the second step, as you can see here, and will run the regression analysis again. In the second step, after interpersonal conflict is removed from the model, you can see that the F statistic changes to 38.316 and it's still statistically significant. And you can see that the three remained predictors can predict 10.35% of the variation in job performance. And then we have the last table here, which is the regression coefficients table. As you can see, we have three predictors on a standardized version of the patch coefficients and also the standardized version of the patch coefficients. As you can see, based on the T statistics and the P values, all of these three predictors are statistically significant. Also note that all of these F ratios are greater than 2.71. So EQS will not drop any of these predictors from the model in a subsequent run. So this will be the final results of our backward stepwise multiple regression analysis. Okay, this is all about multiple stepwise multiple regression analysis, both forward and backward stepwise multiple regression analysis, and I hope you enjoyed watching this video. Thanks for watching.